If cos of theta is 3/8 and it's not in quadrant 1, find sine of theta and tan of theta. Well, first of all, if theta is not in quadrant 1, what quadrant is it in? Quadrant 4. How do you know? Because the cast rule, cos is positive. Cos is positive in quadrant 1 and quadrant 4, but it's not in quadrant 1, so it must be in quadrant 4. And because we're doing trigonometry, most of the time, the thing that's going to help us is drawing a triangle. When we draw our triangle, we always draw it back to the nearest x-axis so that our triangle includes our reference angle. And on that triangle, if cos is 3/8, I can label adjacent over hypotenuse. And like I said before, you guys are going to get really, really good at a squared plus b squared equals c squared. The other side is going to be the square root of how'd you do? 55? Right? 64 minus 9, 55. So now that you have your triangle, it's not hard to find sine of theta. Well, sine of theta on the triangle is opposite over hypotenuse. But just writing opposite over hypotenuse is not quite right. Because it's in quadrant 4, according to our cast rule, what's going to happen to sine in quadrant 4? It's going to be negative. So we use our triangle to get the ratio, and then our cast rule to decide whether it's positive or negative. And tan of theta? Opposite over adjacent and negative as well. Example number 2. Is the point on the unit circle? Well, the first answer that students often come up to on this one is they say no, because we just made our unit circles and that's not one of the ones on there. However, when you think about your unit circle, there's my unit circle, we only did those points. But I would still say that green point is on the unit circle even though I haven't labeled it. In fact, there's an infinite amount of points on the unit circle. And there's an infinite amount of points that are not on the circle. So guessing really isn't a good choice. But the question is this point, root 3 over 3 and root 6 over 3, on the unit circle? So again, what we need to start thinking about is some of our big ideas. What do we know about points on the unit circle? Well, our 3 big ideas were that points are cos theta comma sine theta. Tan was sine over cos. And that sine squared plus cos squared always equals 1. So in this case, we're going to use the definition of a unit circle, right? Our definition of our unit circle, or this. Oh, I don't want to use red. Right? Sine squared theta plus cos squared theta equals 1 is true on the unit circle when this is y squared plus x squared equals 1. If sine squared plus cos squared equals 1, that point is on the unit circle. So what we can do as a check here is we can ask, is root 6 over 3 squared plus root 3 over 3 squared equal to 1? If it is, then that point is on the unit circle. If it is not, then that point is not on the unit circle. Points on the unit circle have to follow the definition of a circle, which is x squared plus y squared. Unit circle, the radius is 1. If I check this, root 6 squared is 6 over 9. Root 3 squared is 3. 3 squared is 9. 6 over 9 plus 3 over 9 is 9 over 9. Oh, we were so close. We were supposed to get 1. Yes. That point is on the unit circle. So we get these big ideas asked in different ways, and that is part of what makes this unit hard at the beginning is a question like this. If you haven't seen it before, would you think of using the big ideas to help you solve it? So right now, this one would be a big problem-solving one. Now that you've seen one like this, maybe you would do better moving forward. So one of the things that I'm going to try to do over the next little bit is try to introduce you to all the different types of questions that can be asked now that we've learned the unit circle. If negative 12, 13, comma y is a point on the unit circle in quadrant 3, find y. And just like question 1, if you know what quadrant something's in, probably a really good strategy is to draw a triangle. We're dealing with trigonometry here. We're dealing with the unit circle. The unit circle is related to triangles, related to sine, cosine, tan. It's in quadrant 3. Draw a triangle back to your nearest x-axis and label your reference angle. Now, what do we know about this triangle? We know the x-coordinate. If we know the x-coordinate from our big ideas, we know is sine of theta or cos of theta equal to negative 12 over 3? Cos. Cos of theta is negative 12 over 13 because that's the x-coordinate on the unit circle. And if we know that cos of theta is negative 12 over 13, we can label part of this triangle. We can label that adjacent over hypotenuse. This length would be 12. This length would be 13. Notice I didn't label it as negative 12 because on that triangle, I'm actually measuring that distance. Yes, it did go 12 to the left, and it wouldn't be wrong if you wrote negative 12. But with a reference angle, we're actually thinking about the triangle and lengths of that triangle, so it makes sense to label everything as positive. My triangle is not drawn to scale, but do you recognize this triangle from yesterday? It's the famous 5, 12, 13 triangle. A squared plus b squared equals c squared. So if you want to find y, well, on your unit circle, y is sine of theta. Okay? So sine of theta, opposite over hypotenuse, negative because it's in quadrant 3. Why wouldn't I get full marks in this question? Yes, yes. So y equals, right? The question said find y. We found sine theta. In our brains, we are like sine theta equals y, but just because it's in our brains, it does mean we still need to clarify it on the question as well, that we understand that sine is y, so y is negative 5 over 13. This is one way I like this method. If you can draw a triangle and use a triangle, I find that works the fastest and the easiest. You could also use the definition of the circle and do negative 12 over 13 squared plus y squared equals 1. And solve that, and you would get y is equal to plus or minus 5 over 13, but because it's in quadrant 4, you would choose negative 5 over 13. That has a little bit more work in it. If you can draw the triangle, I find that that's often the quickest and easiest way to solve it. That doesn't mean there's not other methods that you could use. Because the quadrant is so important for drawing the triangle, for the cast rule, one of the things that we're going to look at is how can we tell what quadrant an angle is in, and how can we do that quickly? And we're going to look at calculator methods and non-calculator methods. So starting in degrees, you have an angle of 4,300 degrees, right? You just went skiing, you went in the air, you spun a bunch of times, you didn't quite land it, but your friend said you did 4,300 degrees in the air. That would really be quite amazing. How many full revolutions did you do? What quadrant did you land in, which made you fall? Because you needed to be perfect to land it straight. Well, one way you could do it is with your calculator. If you do 4,300 degrees divided by 360, it comes out to 11.94. And 11 means you've gone around 11 full times. The 0.94, does it make sense that this is a quarter, this is a half, this is 3/4, this is all the way around? So 0.94 happens to be in quadrant 4. So 4,300 degrees is in quadrant 4.
Can we please have all members of the cross-country team please report to the west foyer right away? That's all members of the cross-country team. Thank you.
If you were doing this without your calculator, probably I would look at this. I would say, okay, 4,300 degrees. Can you see that 10 times around is 3,600 degrees? So if I subtracted 3,600 degrees, well, that's a big degree symbol. 3,600 degrees. That would leave me with 700 degrees. 700 degrees is still more than once around. If I subtract 360 again, that leaves me at 340 degrees. So 340 degrees, that's easier to see. It ends in quadrant 4. 4,300 degrees is coterminal, or ends at the same place as 340 degrees. So I would know that it ends in quadrant 4. I think that's, so all the quadrants are listed there. I mean, if you knew, I took away 10 first because it made the math easier and then took away one more, but you could have taken away 11. And we would call 340 degrees, does it make sense when I say it's the first positive angle that's coterminal with it? Because if we go back to our diagram here, 0.94 ends here, the first positive one would be the first angle that stops there. 4,300 goes around 11 times before it stops there. But the first positive coterminal angle is 340 degrees. And now in radians, we're going to look at, we could do radians with our calculator as well. Same strategy. If you had a calculator, you could take negative 23 pi over 6 and divide it by 2 pi. Just like we divided by 360 and you get a decimal and you could use exactly the same, but most of the time our radian questions are non-calculator. So if we want to find out what quadrant it's in and state the first positive angle that's coterminal with it, a strategy that we're going to use is changing the fraction, which is an improper fraction right now, to a mixed fraction. So negative 23 over 6 is the same as negative 3 and 5/6. And so we have negative 3 and 5/6. So if I have negative 23 pi over 6, it's equal to negative 3 and 5/6 pi. And the logic that we're going to use is that on our unit circle, or on our circle in radians, here we have 0. Just move this over a bit. Here we have 0. Here we would have pi. All the way around would be 2 pi. If you went again, here we would have 3 pi. And then we went all the way around a second time, we'd have 4 pi. And then 5 pi. And we're counting in terms of pi. Pi radians is only halfway around a circle. Does that make sense? 2 pi is all the way around. Pi radians is halfway around. So now, with negative 3 and 5/6, I'm starting in standard position. I need to go negative 3. 1 pi negative direction, 2 pi negative direction. Negative 3 will end on the negative x-axis. Odd numbers end on the negative x-axis. Even numbers would end on the positive x-axis. So now I've gone negative 3. I need to go negative 3 and 5/6. 5/6 is more than half. So I need to go more than half, and I'm going to end in quadrant 1. Number of rotations of pi, negative 3, and then 5/6 is more than 1. That ends in quadrant 1. Now the beautiful thing about radians is when we try to find the first positive angle coterminal with this, the mental math is so easy. What family is negative 3 and 5/6 pi belong to? It belongs to the pi over 6 family. Really easy to see because of the fraction. If it belongs to the pi over 6 family, what's our pi over 6 family in quadrant 1? Just pi over 6. So negative 23 pi over 6 is coterminal with pi over 6. Now I've written it out by adding 4 pi, because you can just keep adding 2 pi until you got an answer that was between 0 and 2 pi. But in this case, if you draw the diagram, and once you figure out it's in quadrant 1, it is so easy to say it's coterminal with pi over 6. So I have an activity or a worksheet to help us learn this. We're going to start this in the class after lunch.